Well, hello, Mr. Crowley here for AP Environmental Science. That's right. Yep, we're talking air pollution, which would be considered the introduction of chemicals, particulate matter, sometimes abbreviated PM, and dependent on the size, the more damage it can do to you and other organisms, including organisms, microorganisms in the atmosphere. And we talk about the atmosphere, you generally talk about the lower atmosphere, the troposphere, where they're at concentrations high enough to harm plants, animals like yourself, and materials such as buildings, or they can alter the ecosystem. So, just really quick, we mentioned about stratospheric ozone, all right, and stratospheric ozone different from tropospheric ozone, which we'll talk about as secondary pollutants as we go through. Okay, so anyway, hope everyone's doing all right, and let's talk air pollution here. All right, so there's been a significant decrease, believe it or not, since the 1970s. Okay, this is a successful environmental story, and the reason why I say that too is 1970. It's now 2020. We're now celebrating the 50th anniversary of Earth Day this week, actually, which is pretty exciting. And a lot of efforts made in the 60s and 70s have helped to clean up the air, right, through regulation. I know we don't like hearing regulation, 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 but sometimes you need the government to step in and say, listen, you need to reduce this, this, or you're going to pay a fine, right? Or they incentivize it, right? They say, listen, if you don't do this, then we'll give you, credit, or you can sell off what you don't use. All right. So that has seemed to work with some of the different things with air pollution. And here's just a graph of showing the changes in the GDP, right? How many miles we travel, right? The growth in population, all the extra energy that we consume, the CO2 emissions, and then finally, you can't see it, but the negative 68%, let me see if you can see that there. Oh, there we go, there we go. Okay. Is just the overall, everything's increasing, but one major decrease that we've seen since 1980 to 2018 are the six main primary pollutants. All right. So can you name those six primary pollutants? Hold on one sec here, and let me go here. Okay, hopefully you said, boom, nitrogen oxides, VOCs, volatile organic compounds, sulfur dioxides, particulate matter, carbon monoxide, and there's one on this that's missing, which would be lead. Okay, and so those are the six primary. And primary, they're just primary just means that it's being emitted directly to the atmosphere through some source. Okay, and some of those sources they show right here, which would be, you can see the bulk of it is from transportation, like our cars. Stationary fuel combustion is generally the making of electricity through burning of fossil fuels. Industrial processes, solid waste disposal, and then the miscellaneous, right? And remember, there are natural sources for these as well, but the bulk is coming really from us. And remember, a big part of it is, transportation, which is key. Okay, so all right, so those are our primary pollutants. Remember, secondary pollutants generally is a chemical reaction that occurs with a primary pollutant and some other energy source like sunlight. Sunlight's a great thing that helps interact, and warmer conditions. Okay, so let's just advance a little bit here. Just similar to what we were just talking about, how the GDP has increased and overall emissions have come down significantly. And I just want to direct you to this website here, which is great. I'll link it up there for you. And the EPA puts together this really great interactive air quality site here, which is kind of cool. All right, and you can scroll through, and There's a lot of great things in here. And there it is, 1970, the implementation of the Clean Air Act and technology advancements from American innovators have dramatically improved air quality in the U.S. Cleaner air provides important public health benefits, as we know. Okay. All right. So let me just go here for a minute. Let me just. Oh, I don't need to do. So, like we were saying, 1970 Clean Air Act. Later on in the early 90s, we create an amendment to reduce the sulfur dioxide, something we talked about with cap and trade earlier in the year. And that was more of an incentive versus that command and control, right? Incentivizing companies to reduce their sulfur emissions. Because we know sulfur, by generally burning coal, sulfur interacts with water vapor in the atmosphere to produce acid rain, acid precipitation, right? Which that's what we're talking about. Generally changing an ecosystem, changing the chemistry of water and soil. Fish die, right? Organisms in the water die. Plants in the soil die, et cetera, et cetera. Aside from the damage it does to buildings and monuments and so forth, right? Okay, so let's take a look at the 6 primary pollutants, all right, starting with carbon monoxide. Okay, so I put the picture up over here because maybe some of you have seen a carbon monoxide detector in your home. Hopefully you all have one of those. It's working. You should test it to make sure it's functioning. You're supposed to change the batteries in it every so often. Anyway, so carbon monoxide, probably the biggest concern would be with carbon monoxide would be in enclosed spaces, running the car inside the house, a furnace not venting properly. Your home's going to build up with carbon monoxide, all right? And it even says here, single largest source are automobiles, all right? And most dangerous in enclosed spaces. And remember, what makes it dangerous is that the hemoglobin in your blood will bind uh, to the carbon monoxide, thinking it's oxygen. And before you know it, you pass out and you potentially would die, right? And believe it or not, cigarette smoke is another source of it. I'm not sure if vapes are as well. I haven't done any research on that, but that would be pretty interesting to know. Okay, so that's carbon monoxide, right? This is just showing you a graph. Don't worry so much about it. Okay, and particulate matter. All right, so we're talking about small, minute pieces of solid material dispersed into the atmosphere. Think of it like dust, dirt, soot, smoke, soil, okay? All small little particles. All right. And the smaller they are, the more likely they are to embed in your lung. All right. And potentially interfere with the ability of the lung to exchange gases. The smaller ones, and we talk about 2.5, we're talking about micrometers. All right. Tiny little particles. All right. That can be carcinogen or carcinogenic, which means that they are cancer causing. Right. So, think about it. The car exhaust releases particulate matter. All right. There's mufflers and so forth and different contraptions on the car to reduce that particulate matter. But the car exhaust releases particulate matter in addition to other things. A power plant, right? That's burning of fossil fuels, releasing particulate matter. And once again, we're using filtrations, we're using different things to reduce that particulate matter, but it does still exist. Okay. And we say here, caused by travel on the highway and the roads, construction sites, campfires. We said car exhaust, uh, many different sources of particulate matter. I mean, pollen is a particulate matter, right? Just dust in the atmosphere. Just the smaller it is, the more damage it could potentially have to your health. Okay, so just particulate matter, pretty big deal. Okay, all right. Next, just a little picture, just comparing the different sizes of the particulate matter. All right, and we'll just keep moving along here. And remember, those are microns or micrometers. Okay, sulfur dioxide, something we talked about earlier in the year. Sulfur and oxygen compound, all right, produced when sulfur containing fossil fuels. Generally, we think of as coal having high percentages of sulfur. Okay. So when you burn it, it releases sulfur dioxide. Smoke caused in part from sulfur dioxide combines with fog and creates a term called smog. All right. And we'll talk a little bit about smog when we get to secondary air pollution. Respiratory problems like asthma, plants and animal tissue adversely affected, and interact with water to create acid rain. And we're mentioning about acid rain. And we'll talk about smog as well. Both smog and acid rain would be considered secondary pollutants. Okay, nitrogen oxides. All right, they form when the combustion takes place in the air. All right, it tends to be colorless and odorless. For nitrogen oxides, nitrogen oxide, and nitrogen dioxide tends to be reddish brown. Okay, and your car generally releases nitrogen oxides. All right, and these guys are also responsible for producing ozone and another thing called photochemical smog. All right, and anyway, it says here automobile engine is the primary source, but natural sources from fires, soil, and fertilizer. Just the the biogeochemical processes put nitrogen oxides into the atmosphere. Um, through agriculture is a big source, not just driving the equipment, but just the soil and so forth. As we put fertilizers down, and it goes through the different processes of nitrification, denitrification, and so forth. You're going to put more nitrogen oxides into the atmosphere. Right? But cars generally are a big source in our cities for nitrogen oxides. Okay, little picture there. Okay, VOCs, volatile organic compounds, hydrocarbons, okay, which are a group of organic compounds consisting of carbon and hydrogen, evaporated from automobile fuel or remnants of fuel incompletely burned. So basically, if you're pumping gas at the gas station, you get that odor, right? That's a VOC. Guys, VOCs are coming off of, like, if you get a new piece of furniture or carpet in your home, you smell that, and it's, oh, I like that new car smell, or I like that new smell of the furniture and so forth. Those are VOCs, and actually, they're not good for you. Those produce, well, in a home, it's an indoor air pollutant, right, which could be a carcinogen, could be bad for your health, could trigger like an asthma attack or something like that. And something I forgot to mention too earlier, which I'll go back to about asthma with regards to particulate matter. And we'll mention that after I get through all these, okay? Like I said here, release of the carpet, furniture, trees, okay? And like if you've ever smelled a pine forest, those are VOCs, right? But they're also, I think we're more concerned with, the vapors coming off of a fuel pump and so forth, especially in our cities because so many people are pumping gas and so forth, and that's putting high amounts of VOCs. And VOCs combined with other primary pollutants and sunlight can produce secondary pollutants, different types of smogs. Anyway, some of the, if you see here, some of the VOCs down the bottom here, I can't move that. Benzene, okay, acetone, formaldehyde, some of these things you've heard of before. Benzene, that's a really major carcinogen that we definitely want to reduce our exposure to. Okay, and finally, we got lead. All right. And we've done a great job with removing lead from our environment, but it's still there. You think of maybe lead-based paints and so forth, but lead used to be found in our gasoline. So when you go to the gas station, it should say unleaded. They remove the lead and so forth. And lead can enter the body through breathing airborne particles or consuming lead deposited on surfaces. Leaded gasoline was a primary source, which we've eliminated. Okay, the issue with lead is that it can cause cognitive disabilities and kidney damage. Okay, anyway, so yeah, the lead. We've got the six primary pollutants. Wanted to mention before about particulate matter. What we generally see is that even though we've reduced particulate matter through different filtration systems in a lot of our stationary energy creating power plants, like where we burn our fossil fuels to make electricity, we generally see an increase in asthma the closer you are to some of these spots where they are burning these fossil fuels to make electricity because there's higher levels of particulate matter, and particulate matter can trigger asthma attacks. Just wanted to point that out. Is it okay? Let me pause for a minute here. Okay, so what are the ways to prevent air pollution, right? And we said before, regulation, right? Forcing companies to take action, right? But things that we can do too, right? And they show the little picture of you turning off the lights. You turning off the light, right? I turn off the light here, and let me just bring my light down here, right? I'm required less. Oops, I'm using less energy, right? I'm also using a more efficient bulb here. This actually, right here, is an LED bulb, which uses it's I can put my hand on it. It was just on. It produces very little heat, all right? And objects that produce very little heat generally are very efficient, and that's like the LEDs or the compact fluorescent bulbs and so forth, making things more energy efficient, all right? Help to reduce the pollution in the atmosphere, making cars more efficient, right? The CAFE standards, right, for cars that make them go more miles per gallon and so forth, all ways to reduce air pollution, all right? As we said, cap and trade on sulfur dioxide. They've even talked about cap and trade for carbon dioxide emissions. Remember, carbon dioxide, by the way, not the same thing as carbon monoxide. Carbon dioxide is not considered an air pollutant, although we want to reduce our carbon emissions, our carbon dioxide emissions, our methane emissions, because we know those contribute to the greenhouse effect. All right, and but anyway, aside from that, because I don't want to jump around too much. All right, what are some things? All right, so let me jump right here. I'm going to slide around to a few, but look at this right here. Okay, controlling air pollution, nitrogen oxides, also carbon monoxide through the catalytic converter. Right, and the catalytic converter was another requirement. The federal government asked all U.S. car makers, all cars that were coming into the United States, to have a catalytic converter to help reduce the nitrogen oxides and the carbon monoxide emissions, right? And you can see they're just showing it in here and so forth. Okay, actually, I think I have that on another slide as well somewhere in here. Let me just see, where am I? Let me go down here, back to OB. Oh yeah, okay. Yeah, so that was just, it also removes some of the VOCs and hydrocarbons and so forth. And once again, still releases carbon dioxide. All right, so let's move along here. All right, let me just go back to my testify here. And so the type of fuel you're burning, all right, will also determine how much of that air pollution is produced. All right, and they just show an example here of the different grades of coal, going from peat, the planty matter, all the way down to anthracitic coal, which is a metamorphic coal, which is very dense, and it actually has lower sulfur content. Okay, when you get up over in here, you're going to put more particulate matter into the atmosphere, more sulfur dioxide into the atmosphere, et cetera, et cetera. Okay, burning coal versus oil versus natural gas. One of the reasons why we switched to natural gas vehicles for like some of our buses and so forth, because it was supposed to produce less air pollution, right? other things. This is just showing the reduction, another way to reduce sulfur dioxide. This was some of the technologies put in, all right? And if you see here, the bottom line is the byproduct when you introduce calcium carbonate in the presence of that sulfur dioxide, you can make calcium sulfate. Okay, that's the byproduct. And actually, what these energy plants can do as a byproduct is they can make drywall. That's the stuff that we make walls out of, and so forth. So that's one thing to reduce the sulfur dioxide, to reduce nitrogen oxides in some of our coal burning plants. All right, burning them at lower temperatures with decreased levels of oxygen present. Okay. There's the catalytic converter, as I was saying. Okay. Obviously, construction sites are going to produce particulate matter and so forth. And let's go here. Okay. Some filtration, what they call the baghouse filter, to reduce particulate matter within a energy power plant and so forth. We talk about energy power plants. Nuclear energy is not going to really put out particulate matter. We're talking more when you're burning a fossil fuel. Controlling air pollution, once again, speaking of particulate matter, these electrostatic precipitators, all right, and it's just basically using charged particles to capture, to make the particulate matter stick to a surface and so forth. Okay, more filtration, or what we call scrubbers. Okay, another way to reduce our particulate matter, and basically getting the little. It's basically, you can think back to earth science. It's basically using water to adhere to the little particles and so forth, so they settle and then they can be taken somewhere. Yeah, once again, some of the other things here, right? Limiting fireplaces. Believe it or not, bakeries produce a lot of VOCs. All right, so bakeries in the cities, gotta close them all down. No, don't do that. Obviously our driving and carpool lanes, right? All these different things, all right, can help to reduce some of the air pollution and so forth. All right, so let me just pause. Okay, so now we're going to talk a little bit about secondary air pollutants. Okay, so let the screen open up. Secondary air pollutants form under the reaction of primary pollutants, right? You know your 6 primary pollutants, all right? Add some water or some sunlight or some oxygen, a little bit of both, all right? And you've got your secondary pollutants, okay? And let's take a look. We're going to focus in on tropospheric ozone and photochemical smog, because we've spoken about acid rain with regards to sulfuric acid and nitric acid. All right, we talked about that earlier in the year. All right, we've also spoken about stratospheric ozone, and which is another part to this chapter, but we'll do that with some review for the AP exam. All right, so anyway, let's talk about secondary air pollutants, and this one's a good one because really, we are a major contributor to some of these secondary pollutants that are really bad for our health, all right, especially us living so close to cities and so forth, and us driving cars or knowing so many people that drive cars, and there's so many cars on the road and so forth, and sure enough, they show you something like nitrogen oxide being released from the car. Remember, I was just saying too that how a catalytic converter introduced in the 1970s, 1975 to be exact, was meant to reduce nitrogen oxides, and they have. But remember, we put so many cars on the road that we're still putting nitrogen oxides into the atmosphere. Okay, and where it's interacting with oxygen and sunlight to produce O3, which is the ozone. Okay, so let me just here we go. Tropospheric ozone, okay, is a molecule of 3 oxygen atoms bonding to one another. And in the stratosphere, we love ozone, right? Because it absorbs ultraviolet radiation. But we don't love it at the ground level, all right, in the tropospheric zone. it's bad for our lungs. Okay, it's bad for living things. It's bad for plants. It's bad for us. It's bad for, like I said, all living things. All right, and they're just showing you a quick little little, not an animation here, but they're just showing you a little picture here, showing you what it takes. All right, and this really transfers us into when you talk about adding a volatile organic compound. Remember, so you got your gas stations, right, and you're pumping your gas, and those VOCs, those vapors are coming off, right? The nitrogen oxides being released from your car, summertime, sun interacting, right? And you're producing this ozone, all right, that eventually becomes this smog, this photochemical smog. All right, so let's just advance a little bit here. And it's just showing you some of the reactions. All right, that's right from our textbook, by the way. All right, and once again, that's that same picture again. All right, and oh, the damage it does. Right, it destroys the chlorophyll. All right, and so we get to photochemical smog, a mixture of primary and secondary pollutants forms when primary pollutants interact under the influence of sunlight. Only type of air pollution that has not decreased. More cars on the road, right? Urbanization, okay? Even with our regulations and so forth on our vehicles. You take ozone, nitrogen oxides, and VOCs, volatile organic compounds, right? Sunlight and warm temperatures, and you get this photochemical smog, all right? And let me just put my picture over there and the picture there of the bridge. All right, here's just showing you another reaction here. This is the one from the previous one to produce your ozone, right? And you take that ozone, you add some VOCs, and you end up with this photochemical smog, all right? And hold on, let me pause for a minute there, all right? So I have a picture here just showing the photochemical smog. I think that's LA, and it's basically like a ruddy brown haze. And what's bad is just it's really bad for your lungs. All right, it can trigger asthma attacks. People that obviously have that have asthma. If you have any kind of respiratory illness, it can be very dangerous for people. It can be deadly and so forth. All right. And conditions like what we call thermal inversions, you might remember that from the previous with Mr. I can't think of his name, Bozeman, the Bozeman science, Mr. Yeah, all right. But it's just showing sometimes the thermal inversions. A lot of these pollutants get trapped and just make conditions even worse, right? And they're just showing you a little bit of a thermal inversion when you have that warmer air sitting up on top of the cooler conditions and so forth. All right, so as far as air pollution, we're going to stop there. All right, and I'll push out some other things for you to look at and play